Hey, hey everyone. Looks like we're live. Cool. So today, just going to be doing a little OSRS AFK wood cutting, and we're going to be working on our coaching product here using depth models, object detection models. So yeah, and some generative AI stuff. Let me pull up. Let's take a look at what we completed yesterday, or on the last stream. Okay. Yeah, so on the last stream, we were pretty much able to get scheduled reports done. So if I come to alerts here, you can see we can set up a scheduled report, a critical event scheduled report, a stop report, idling report, and we can schedule these reports. We created some new Postgres tables for scheduled reports. So now when you enter it or set up a scheduled report on the front end, we add it to the Postgres table. And we're using a tool called Job Runner, which is a Java tool, job scheduler. So we're going to be setting up a smart cron for this scheduled report to fire it off every Monday. Or we'll think of exactly when we need to run that cron job. Because if we have many different users that all have scheduled reports set up, we don't want to overload the system. So let's open up our text edit pad here. So let's see, let's get a new document. Let's see what we got. Let's say we got our to-do list. We got the smart cron for scheduled reports. Scale up the node group for the coaching service. M5.large. Okay. Review new object detection models. We are on YOLO v4 now. Okay. Review alternative depth models. We are using the Intel depth. We're gonna review the coaching system prompt and try to improve it. Build coaching system front end. Okay. Yeah, so we added scheduled reports. We also got clusters done, and I actually, this is our staging server system, and all of these changes we'll walk through here, we actually deployed to production. Let's make sure we're chopping our use here. Yeah, so we also deployed these clusters. So these are 3D objects right here. And when we identify a cluster, we hide them. We overlay this CSS on top of the 3JS Google Maps overlay. And what we can do actually is we can say we deployed clusters. Hold on, let's see what else we deployed. Yeah, so we deployed the clusters and the media player. I think were the two biggest items that we deployed. We deployed the new media player and the super clusters. Can you review what we did and tell us in detail exactly how we completed these changes? We're on live stream now. You see, I sent a email earlier. Yeah, so we did some liquid glass stuff also. So we have, if I click reports here, this is kind of like a liquid glass component here. I actually can't show you the live video component, but we also, on the other system, we also turned this component, or we're using liquid glass now for this component. So we have liquid glass on this component and also the live video component. And also when we come to reports and run a report and review the media, on the production system, we also added a liquid glass effect now to this component as well. So on the last few streams, we've been working on this media player, we worked on scheduled reports, and we worked on these clusters, and we're able to get all of this deployed to the production system. So now what we're going to work on during today's stream is actually going to be kind of fun. So let me pull this up here. See if we can... Okay. So this is the coaching service. And we have dash cameras in vehicles, and that's our kind of our core product. And we're really focused on fleet safety right now. So one of the solutions that I'm working on is an AI coaching solution. So we're using object detection model, a depth model, and also OpenAI 4.0 to build safety reports or coaching reports for companies that have fleets of vehicles. So I'll go ahead and play this. So this is using an Intel depth model, an object detection model, to build this scene here. So we'll go ahead and play this. Let me grab caffeine here. Kind of keep chopping here. Got it. So what we're going to do is say Can you review the coaching service and let us know which depth model and object detection model we're using today? So pretty much we pass in an MP4 to this coaching service. We use the depth model and the object detection model to identify any objects in the scene and how far away those objects are from the vehicle. So again, we'll play this one more time here. Okay, so let's review here which models we're using. Okay, so we're using Midas DPT large. And so search this up for anyone that's interested. Okay, so we're using this model for the depth detection. And then we're using YOLO V4. So this is YOLO V4, which is an object detection model, and we're using coco.names. So pretty much this object detection model can identify these different objects. So let me see. Say I'm using YOLO V4 for my telematics video business. Which objects are relevant for me? So obviously not all of these objects are going to be relevant. Let's keep reading here. So both of these are loaded at runtime. Now, and I'm not sure that this is the best way to do this, and I'm open to really any advice on this, but I have this model on AWS S3. I pull it down and we store it in the cache at runtime. Yeah, so one thing to mention too is that right now I'm running this model on an M5.large, so we're actually it's CPU bound. We don't have it on a GPU server. We don't have a ton of demand for this feature yet. Customers are still kind of getting used to AI, and they're not ready to go all in yet. Yeah, so we're not using GPU inferencing. I want to improve this service, but we don't want to make any modifications yet. I know that YOLO v4 is an older object detection model. What are some alternatives that we could use instead of the existing models that would be an improvement or give more accuracy with low latency? I only want to use open source models that are free to use for commercial use or are not very permissive. Yeah, right now I want to be able to run this service on an M5 large. I don't want to have to pay for GPU instances from AWS as they are a bit pricey. Okay, let's see here. If we change the Midas model to a smaller variant, it won't be as accurate, right? I'm already a bit concerned about the accuracy now. It's moving, okay. Clear recipe, what I recommend. Okay, so just so I understand right now, you're recommending using a smaller, more lightweight Midas depth model and then upgrading to a newer YOLO model, is that right? Okay. Okay, right now I have the node group scaled down that the coaching service containers run on. Can you? Yeah, so right now the node group that the coaching service. Hold on. Yeah, so right now the node group that the coaching service is deployed on is scaled down, so we're going to have to scale it up. Can you check which node groups we have today? Yeah, use the kubectl command to get the current node groups. Yes, run the command to check the current node groups. Yeah, let's scale the coaching node group to 1. Okay. Yeah, it's not credential. Okay, so did we scale up the coaching node? I don't remember it being named coaching nodes. Yeah, I'm a little confused because I thought that the node group was called Coaching Solution Nodes Large. Run a command to just check all node groups. Okay, got it. Okay, nice. Now, do we need to modify the pod on the coaching service so it deploys on the right node group? So weird. So we don't have any node group with this name right now. Guess we're doing changing some songs here. Okay. Okay, cool. Nice and relaxing lo-fi. Okay. Nice. So yeah, I guess we just want to use the right selector. So change the selector node group name. Branch main. Okay. Okay, that pod's running. Okay, the coaching pod is running now. I'm going to send an event to this service. Can you open the logs? Okay, good. Make sure you follow the log. Keep it open and tail it. Okay, nice. So now, go to reports, go to critical events. Let's check out this event. It's a forward collision warning event. So what we're gonna do is we're gonna send this event here. Inspect. Let's go to network. Okay, nice. So it just sent the event. So it sent this, this is the payload. Nice, so here it's grabbing the YOLO v4 config, the YOLO v4 weights, Coco names. Here it's downloading the Midas model from Torch Hub, storing it in cache. Here's the endpoint standing up at the port. Here's the post request coming in. And it's actually still running now. So it does take a long time to run off on the CPU. I guess it's doing the inferencing on the CPU, which is pretty slow. I know that we have a queue system set up. So like if 5 requests come in, we just queue them up and run them one at a time. Extreme speed is not critical now. I'm kind of doing post-processing, so we're not doing it in real time. We're doing this on historical events. At some point, we want to do this all in real time. Keep dropping off our logs. Nice. Okay. So it just sent this data to the communication service. It actually should have sent it to my email here. Okay, nice. So I can actually show this to you guys. So here, we actually sent this event to my email. So I can go ahead and open up this coaching report. Let's see. So driver was involved in an ADAS forward collision warning event. So we kind of pass in the event that we get from the camera and add it to this transcript. We pass in the speed. Then we see if we can detect any objects. And then after we build the transcript, we pass all of that up to OpenAI and ask it to build some coaching questions. So I'm going to say, I just ran this event through the coaching service. Can you review the logs and see how we can improve? Okay, I want you to check out to a new branch, and then let's add comprehensive logging to this service, and then we'll see how we can improve it. You can run git status, but you need to go into the coaching subdirectory, and that is a Git repository. Okay. Okay. Okay, we're committing the logging here. I don't usually set the upstream, I just push to origin. Can you explain this to me? Pretty sure the upstream is just so you can do git push, but now I'm gonna come and look at this code that just got pushed to the new branch in GitHub. So let me see. Go to coaching. Import logging, import time. Do we need to run npm install or add these new imports to the Docker file? Okay, so the imports we added are just standard Python libraries, so they should work fine. I'm gonna go ahead and merge this or create the PR. Okay, some checks already failed. Let's see. Okay, the build failed. Let me paste this back into VS Code. Okay. So we just tried to add some logging to the coaching service, and we pushed it to GitHub. We tried to build the project and it failed. I'm pushing another new change here. Let's see. Go back to the PR. Let's go to pull request. Come back here. Okay, the project's building again. This. So this image actually takes a while to build, but let me I'll show you guys here. Okay. So here's the Docker image building. Okay. The Docker image takes a really, really long time to build. Do you understand why that's happening? Let's see if this image is still building. Yeah, image is still building. I think the image actually takes almost 10 minutes to build. Oh, there we go. Okay, the image is done building. Let's do a rollout restart. Why are we setting the image like that? Can't we just do a rollout restart and it will pull the fresh image from Docker Hub? Okay, yeah, we use the same image tag. Let's do a fresh rollout restart. Okay, follow the logs. I'm about to send another event to the coaching service, and then we can review the logs together. Hey, if you're just joining, we're working on the coaching service right now. So we're trying to improve the coaching service. Right now, we're using an Intel large model for object detection. I'm sorry, for depth. And we're using a YOLO v4 for object detection. And we're building a transcript of the scene and then building some coaching questions for a driver. And right now we're adding some comprehensive logging to this service and some comprehensive logging to this service. And then we're going to try and prove it. Let's see. Okay. So now I'm going to send a... So let's come here and let's go to the front end here. Let's go to reports, critical event report, run this report. Okay, so let's watch one of these events here. So this is a forward collision warning. I think we might have already done this one. Let's go back a little further if we can. Okay. So let's try, let's see this one. Okay, there we go. So let's run, if I come to inspect, network, let's run this forward collision. Let's check it again. Okay, there we go. Let's run this one. Hit OK. Okay, nice. We can see that it just sent the request to the coaching service. I'm gonna come back. And we should see in the logs here the request come in. Okay, nice. The request is coming in. And we should see our logs here. Okay, we just sent the event to the service. I can see the logging now in the terminal. Now, if I run this, it's going to interrupt the terminal. So I'm... Huh. Now, I don't know if the latest changes just broke the alert service. Let's come... I was expecting to get an email like this, and I can't tell if the service is... stuck or if it's actually executing right now. I'm not familiar with this. We just added some logging to the coaching service. Can you review these errors? Let's just go ahead and run the logs. Yeah, so I noticed that this service was working before we added the comprehensive logging. So why did the service get stuck after adding the logging? Should we test it again? Let's go drop off our logs here. Yeah, let's do another rollout restart, and then we can test it again. Well, there was some sort of timeout, but we're about to test it again here. Okay. We're just restarting the pod. Okay, tail the logs and follow them. Okay. Okay, we have the logs open. Service is up. Let's come back to here. It's over. Put this that right here. This here. Okay. So what we're gonna do is we're gonna go find another event. Go to critical events, generate these critical events again. Okay, let's see this one. Looking for events that have objects, clearly have objects in them. All right, I think this one is 755. All right, the one at 755. Let's go ahead and okay, I see the request just came in. So pretty sure we just posted something to this depth map here. And then it said loading cached Midas model using the cache found here. Oh, there we go. Nice, so it is working. Okay, it worked. Nice. So if I come to my email here, okay. So here you can see, so this is actually in kilometers per hour, and we're gonna fix that. But there, let's come here. Okay. So here you can see the object detection. So I'm gonna say Okay, great. We just successfully executed the coaching service on one of the events. Can you review the logs and let me know your thoughts? How hard would it be to implement the latest object detection model from YOLO? Take the simplest approach and use industry best practices. I want you to swap out YOLO v4 for the latest object detection model. I see that you're still using Coco names. What objects can we identify with the latest YOLO model? We're in the telematics video business, so things like cell phone use, seatbelt distraction are important to us. So do we have to use the Coco objects, or there's a new list of objects we can use? I'm confused because YOLO 4. I'm kind of confused because YOLO 4 is already detecting the Coco names objects. Do we need to update this? Onto 80 objects in this list. Okay, so YOLO V8 detects the same objects as YOLO V4. I assume it's just better accuracy. Can we use some existing data sets that are free, open source to do this? How do you train YOLO V8 on new annotated images? You give me links for all of these data sets. How can we train YOLO V8 on these data sets? Yeah, let's pull these publicly available data sets and then start training YOLO V8 and seatbelt, distraction, and phone use. Okay, so these publicly available data sets have permissive license. Can we reference the data sets that are available and then create our own synthetic data to train YOLO V8? Ooh. Guys, I'm gonna use the restroom. I'll be right back. Okay. All right, I'm back. Hey guys, if you're just joining, we're looking into how to train a object detection model right now. We're using an Intel depth model and a YOLO object detection model to detect objects inside of an MP4 video. And then we're creating coaching reports with that data. So we're creating these coaching reports. And right now, I'm looking into a tool called Openverse and Flickr, which are tools that you can use to build data sets. So the idea is to use these tools to try to build a data set and then create our own synthetic data to help train the object detection model on seatbelt, distraction, phone use, stuff like that. So let's see. Okay, so we got a new README. Here's the Openverse downloader.py. Let's see what this is, what this looks like. Okay, so this is actually called the Openverse API, and this is to help us get some images. So if you're just joining now, we're working on a coaching tool. So we have customers that have dash cams in their vehicle, and we're using an Intel model to check the depth of these objects, and then we're using YOLO v4 to classify these objects. And then what we do is we build a coaching report. So we figure out what objects are in the scene. We pass in the event that we have from the camera. So the camera does edge AI events. So stuff like forward collision warning, lane departure warning, following too closely, turn, accelerate, hard brake, shock, severe shock. And we have the speed of the event. So that's part of the transcript. Then we look for any objects that we can find in the video. Then we pass all of this to OpenAI and ask it to return some coaching questions for us. So right now, actually, there should be a file called Coco names somewhere here. Let's see. So right now, the YOLO model can only detect these objects here. And phone is one of the objects that it can detect, traffic light, car, truck. But things like seatbelt and texting, smoking, stuff like that, YOLO cannot detect that. Now, there is a way for us to kind of curate this data and then try to train YOLO. So that's what we're trying to do now. So let's see. Searches downloads from Openverse and Flickr with license filters. Saves JSON sidecars per image and maintains a global attribution.csv. Okay. So. And guys, on the last stream, I'll just show you some of the work we're able to get done. We're able to get done clusters. So this is actually Three.js overlay on top of a Google map, and these are 3D objects on the map. And I'll show you another cool Three.js thing that we're doing here. Let's see. So you can also see we're doing different 3.js simulations. and this is one of them. But some of the features that we finished on stream together is actually clusters. So once we identify two markers, 3D markers that are within proximity of each other, we'll create these clusters to show are the device active or inactive. And also a new media player. So let's see. So this is a new media player that we just added, which is pretty cool. And you can expand this to full screen and play these videos at the same time. This is an iframe, so they don't play together with the MP4, but I can play these, pause them, back to the sequential view, and this will cycle through. But anyways, going back to what we were working on. So here, these are all of the objects that we can detect. And just to show you what the alert looks like, after we, so pretty much a customer can come in here, go to critical events, and look at a event, and they're able to run coaching on that event. And that will send this request to our coaching service. And our coaching service is using Intel DPT large for depth. So we're using this model to help detect the depth of the objects in the scene. So again, here's an example. So here, that's the Intel model trying to detect the depth of these objects or the distance of the objects. And that's how we're trying to determine, which objects are relevant, right? And how far are they away from the vehicle. So this is the Intel depth model, and then YOLO for object detection. And then what we'll do is after we generate the video, the AI analysis, we push it up into S3. Same with the coaching report. And so you can just download this and open it up, right? So what we're trying to do now is, right now this service is actually running on an M5 large, which is not a GPU server. So all of this runs, it's CPU bound, so it's running on the CPU. And so we're really just trying, and it's a bit slow. And so really what we did is we're trying to add some logging and review this, see if we can maybe upgrade from YOLO V4 to YOLO V8 to get some maybe increased speed and increased accuracy. And also see if maybe there's a better depth model that we could use. So I'm just going to say again, can you list out all of the items that we have discussed so far in this chat and explain for a layman what our approach is and what our next steps are? So thanks, guys, if you're joining and hanging out with us here. Just doing a little AFK Old School RuneScape grind in the background, chopping down some trees and working on this this coaching service here. So let's see. Now GPT-5 Mini does get a bit overly verbose, but let's see what it said here. Okay, so we're considering moving from YOLO V4 to YOLO V8. So we're interested in detecting things like the phone in hand, the phone near someone's head, a seatbelt on or off, right? And so we looked at some of these different data sets. And when we looked at these data sets, we actually found that they're not available for commercial use. Can you give me for these data sets? So let's take a look at these data sets here. And if you're in the live chat, or if you're in the watching live, guys, please like and subscribe. It helps a lot. And feel free to ask any questions if you want. So let's see here. Let's look at these different data sets. Okay, so here's the State Farm distracted driving data set. And we got this drive and act data set. Now, and then we have this data set here. Interesting. Okay, so here you can give an idea of kind of what this data set looks like. And it's a synthetic data set. Synthetic data set. So these data sets, I cannot train YOLO V8 and use the model, or use that model inside my app for commercial use. I think it might only be for research purposes. Okay, yeah, so unfortunately, you have to negotiate a commercial license to use any of these data sets. But what we can do is use Openverse and Flickr. But we can use Openverse and Flickr API to find images that we can use to train YOLO V8, right? And then use that data set as reference to create more synthetic data. Let's see what it says here. Okay, how do we get started doing this? And actually what we're gonna do is we're gonna use Claude Sonnet for this actually. Just GPT-5 Mini is doing great. I just want a model that's a bit more concise. So I'm gonna say, come back to here, switch to Sonnet. Claude Sonnet 4. I'm gonna say, can you help us? Let's just use speech to text. Can you help us get started with this? We are new to training models, so we're not familiar with this. So please give a beginner's approach. So this is my first time really even thinking about training a model. I saw the fine-tuning API that OpenAI has, and I have not even used that yet. So this would be training our own model locally, which is pretty cool. Okay, so we're essentially going to download as many interior images of a car as we can. Got to make sure that we have... I assume that these images are going to be kind of big. Nice, we don't even need the API key for this OpenVerse API. We do need... requires free API key. Let's get the Flickr API key. I don't even know what Flickr... I'm not familiar with Flickr. To use Flickr API, you need to have an application key. You know what? We may not... Flickr, we're going to have to apply for that key. Something we can do off stream. So... Okay, so we're literally about to start fetching these images and labeling them to train the model. Okay, let's just use the OpenVerse API for now, because Flickr, we need an API key. And how much space am I going to have on my computer to hold these 2,000 to 3,000 images? Wow, it's not much space at all. Yeah, let's do a quick test to see if it works. Now we can always roll back to an older commit if we break this service, right? All right, let's do the quick test to see if we can download these images. So we're downloading the libraries we need to do this. Okay. Excuse me. Nice. Interesting. So it's like a bunch of images of car interior, but I don't see. Yeah, when I looked at the images, we see a lot of images of the car interior, but I don't see any images with like a driver in the car with a phone up to his ear. Let's say, are you sure we can't use this data? Somewhere images. Excuse me. Okay, there we go. It's better. Let's see, safe driving. Driver hands on the steering wheel. It's better. It's better. Okay, guys, I think actually it's a good spot to stop here. So we learned a lot today. We learned that the latest YOLO model is still only detecting the same objects as our YOLO V4 model. And we're in the telematics video business, so certain events like seatbelt, phone use, smoking, stuff like this is important for us. And so we need to train a model maybe using some of these images. And this will be my last question. Okay, great. I can see that some of these images are what we need. Do we have to go through these images one by one and clean up the ones that are not what we need? So for instance, if we're trying to see someone using their phone in the cab of the vehicle, if there's a picture in that data set where someone is not even in the vehicle at all, do we have to remove that, or we still use that during training? could we use? Okay, guys, this is probably the last question here. Okay, as soon as we get the response here, guys, we're gonna probably end the stream for today. But we definitely learned some stuff here, which is good. Let's see what it says. It's taking a minute here. I mean, I kind of know the answer to this, I guess, but let's try one more time. See what Sonnet says here before we walk away from the stream here. Interesting. Sonnet usually does. Oh, there we go. Nice. So we can do that. I'm going to go ahead and pause here. So we're going to, on the next stream, we'll start digging a bit deeper into this. We're probably going to replace YOLO V4 with YOLO V8. Maybe try to use a more lightweight DPT Intel model for depth. And run it on the CPU and see if we can optimize that and still get the accuracy that we need. And then we're going to think about training the model. So, really looking forward to that. And I'll see everybody on the next stream.